But anyway, okay. So what I'm going to do is start by kind of talk a little bit about integration. So basically, many enterprises have a number of systems nowadays. They will have built some internally, some will be kind of cloud-based systems. They will have some legacy systems, for example. Others they will have acquired from third parties. And obviously, when choosing these systems, they will have chosen these systems for that particular business purpose, right? That's the system which actually solves a particular business problem. And very little attention is usually given to how these systems will talk to one another, for example. That's the basic kind of setup within an enterprise often. And, but eventually, a kind of shared business transaction will have to emerge. The systems will start to have to talk to one another. And they will need to be integrated, basically. So that's kind of the basic idea behind integration. So what kind of use cases are often found? So for example, you could have a kind of information portal scenario. So you have like multiple systems, for example, I don't know, you might have an enterprise selling some service, and some of it might come through in a kind of DIY way where customers go to a website and put in their application there. Some of it might come from a broker, for example. And there might be a need for an information portal, so something which pulls in all that data and gives you a global view of all, for example, the applications for services which are flowing into the company. So that would be kind of one use case. Another use case kind of often encountered is, for example, data replication. So we have two systems, and you need to ensure that they remain synchronized for another. So, for example, I don't know, you might have a merger between two companies. Which are in the same line of business. Each of these companies is using its own systems, and now they need to become one company. What happens? You cannot just switch off one of the enterprise systems and switch everyone, because there's so much investment already there. So, as a stopgap solution, what do? You need to actually synchronize the data. For example, I don't know, you have two different insurance partners, and they've merged into one company now. You will have to actually, the new policies which are coming in, you have to be synchronized between the two systems to ensure that both branches of this merger, for example, have access to all the data in a kind of timely manner. And then you have something more complex, for example, what's called the distributed business process. So, for example, this is a transaction which will span across multiple systems. So, imagine, for example, you're a retailer, for example, and someone orders some stuff. So this thing will involve multiple steps, which affects multiple internal systems. So you have to add the order to one part of the enterprise, to one system of the enterprise, right? And then, for example, from that order, you will have to affect the shipping system of the enterprise. And then you might have an inventory management system, because inventory is running low, so you want to order more of those components, for example. And this is just a sequential a transaction which involves accessing multiple systems, right? So you will have to orchestrate this transaction across multiple systems. But that's an example of a distributed business process. And then you have, these are all the first three are kind of internal to an enterprise. But then you will have kind of, for example, business-to-business use cases. So, for example, just to mention something, we worked on a fixed for example, which you might have probably heard about. For example, Air Malta wanted to expose their inventory to another airline so that inventory could be advertised on another airline portal. So they are exposing their own data and someone else is consuming it. So that's an example of business-to-business integration. So how do you actually integrate these systems? So initially, the first thing which occurs is to have like a point-to-point integration. So you start having applications communicating with one another directly. So this is okay if you have a few applications, but it's not really scalable, because the more systems you have to connect to one another, the more you will run into scalability problems. For example, you have problems like tight coupling between systems. So what happens if you need to replace one of these systems? It will affect every other system which is communicating with it, right? So this is a nightmare scenario in integration, and there will be code bloat, because every system which connects to another system will have to have its own connection code. And there might be different technology. These systems might run on different platforms. So all the connection code is looking different for every different system. So you will need engineers specialized in different technologies. And another kind of annoying thing is that there's no separation of concerns, because you want your application to do one job. You don't want it to be bothered with be concerned with everything, with every other application and how to connect to every other application. It's outside its kind of remit now. So that's a kind of point-to-point integration. With a point-to-point integration, you end up with something like this. So you have like these many connections. It's a spaghetti kind of way of connecting things, and it's not really maintainable. So another approach, popular in integration, is to have an enterprise service bus. So you have like this component, which is the actual service bus. You connect the application to the service bus, and everything inside there will be a messaging system here, which will take messages from each of these systems and take care somehow of forwarding to the other systems. So kind of what have you achieved in this way, kind of architecturally? Well, you have kind of isolated all of the integration logic from each application into here, into the service bus. And basically, what do you get out of that? So you reduce the code load, because by moving the integration logic into the bus, you don't have to put it into your applications, or it will be minimal, the thing which you have to put into your applications. The bus is also kind of platform-neutral medium. So it has the advantage that you only have to understand how to connect to the bus. You don't have to understand how every other application, how to connect to every other application on every platform and every technology. So it's a bit more compact. And often these buses will kind of encapsulate the best in integration design patterns. So you don't have to repeatedly code the same things over and over again. And these, by using these patterns, you get kind of an additional benefit, right? So for example, often you will have like routing components on the bus. So in this way, so a system sends a message to the bus and does not need to know about the target system. The integration logic will route, it's kind of purpose to route to the right system. So if you need to disconnect the target system and put in a new one, right, you just adjust the routing logic. And the original application is not kind of affected. So you get a kind of less coupled design. Also, you will often have kind of transformation element here, transformation components. If you don't have these transformation components, every system needs to be concerned with the format which the target system will use. It will need to first transform the data in a way which the target system will consume, and then actually send it to it. If you have the transformation capability on the bus, you send the data in your native format, and then it's the bus which handles, obviously there's some coding element, but it's less intensive. It will be the bus which handles the actual conversion. Again, you have loose coupling here, because the source application does not need to know about the target format, or about the format of the target application. And you have other things like filtering. For example, you can put your validation onto the bus. So if you have like messages which are kind of illegal for the target system, it will drop it. And you have the kind of other very useful kind of patterns. For example, asynchronous processing. I mean, the target system might not, for example, be always on and ready to receive your messages. So you might need to queue them somehow, for example. This way, you don't need to kind of implement your own queuing mechanism each and every time. So the source system can just send these messages, they will be stored somewhere, the target system will consume them at its own leisure. And also, often you include kind of support for transactional processing. This is very important, because when you start integrating, you want to have one transaction across multiple systems. And then if something goes wrong, you want to be able to roll back across multiple systems. And often you get this kind of transactional processing support. So, and I think this is my last slide actually, but yeah. Just before I go to Justin, so I started kind of this talk with the idea that often these kind of integration problems are caused by not thinking ahead, right? So you first you buy the system and then you think later how you're going to connect stuff together. But at the moment, the rage is about kind of API-led development. So the idea here is to plan ahead, design proper kind of APIs, and use it and have these APIs communicate with one another. And the idea will be that through this kind of data hiding exercise, which is done by the APIs, you will kind of gain two benefits. So the first is that when things start communicating with each other, if the API is kind of well defined and neat and clean, the integration between the two will be easier. So you save, there is an lesser cost, right, to integrate. And also, the other kind of benefit is reuse. Because if you pre-plan how you're going to integrate, right, you can reuse the kind of integration code. So you're not building a custom integration for each project you have, but you're going to think ahead and build those APIs, right, in such a way which you can then reuse them for other systems. And in this way, you kind of build an application network then of things communicating with one another. So you have like less cost and more reuse. It's a way of reusing the integration code. So now I'm going to hand over to Justin. Justin will obviously go slower and into greater depth about this kind of API-led approach. And so this was just laying the carpet for him. So kind of. So you want to come over?
Yes.
Okay.